Hey, what's going on, guys? Let's do this problem right here. The question is asking determine whether the following series converge or diverge. Let's see how we can find it. So here we are going to use the limits comparison test, but before we do that we have to get the dominant terms of this function and check it whether it is converges or diverges. So in order to do that, let's simplify this one first. So this is going to be n is equal to 1 to infinity, and then this is numerator remains the same, n plus 1, and denominator I can multiply this one with this one to simplify this one. So this is going to be 12 n power 4 minus 3 n cube, right? So this is what we have. Now we have to pick up the dominant term in numerator and denominator, and if you look at this one, we have dominant term in numerator, that is n, and in the denominator we have n power 4, right? So what we are going to do is we are going to simplify this one. We can simplify this one as 1 over n cube, because n and one of these n cancels, so that gives us 1 over n cube. And let's see whether this one converges or diverges. And if you look at this one, this is a p series, right? And because we have n power a number, if you have number power n, that is geometric series, n power a number, that's p series. And if the number is greater than 1, that's converges. If the number is less than or equal to 1, that is diverges. So here this number is greater than 1, so this one converges, right? This one converges. And if we take the limits comparison test, and if we get a positive finite number, it means this function also behaves like this one, right? Let's see whether we get a positive finite number. So in order to do that, we have to take the limit comparison test, limit n approaches infinity, and in limit comparison test what we do is we take this function right here and then we divide by this one. So this is going to be n plus 1 over 12 n power 4 minus 3 n cube divided by 1 over n cube. It's same as multiplying by n cube over 1, because when we divide it's going to flip around anyway, right? So instead of doing that, I can simply multiply n cube over 1. And let's do the multiplication and write this one. So here we are going to have limit n approaches infinity, and if I multiply n cube with n plus 1, that's going to give us n power 4 plus n cube, right? And in the denominator we are going to have 12 n power 4 minus 3 n cube. And if you see, our leading values has same power. So if we have same power in the leading values, so the first values are going to be the limit. So here we are going to have 1 over 12, that's going to be the limits, since we have the same power in the first terms. So that's the limit of this one is going to be 1 over 12. This is a positive finite number. So if we get a positive finite number from this limit, it means this function behaves as this function. Therefore, if this is converges, this also converges. This also converges. And that is the final conclusion. And that's how we do the limit comparison test. I hope you guys find this video helpful. See you next time.